Welcome back. I'm Dr. Nami. Dr. Whitty has left you with a problem in the previous session. Now I'm going to teach you the solution. I will read the problem once. A 20 multiplied by 20 mm square cross-section aluminium bar is 400 mm in length. If the bar is subjected to an 1 kilonewton pull, using the definition of stress and strain, show that the displacement can be expressed as displacement delta is equal to force multiplied by length divided by area and elastic modulus. Evaluate the stress and strain in the bar, hence or otherwise find the extension under this load. Describe what is expected when the bar exceeds its elastic limit. Now I will run through the solution once. The stress is given by force divided by the area, and the strain is extension divided by the original length of the bar. Thus the elastic modulus is defined as stress divided by strain. Stress in this case is force divided by the area, which is over here, and the strain is given by extension divided by the length of the bar. Thus E is equal to force times force multiplied by length divided by area multiplied by extension. We transpose the extension to the left hand side. Thus the equation now becomes extension is equivalent to force multiplied by length divided by area and elastic modulus. The stress can now be evaluated via the definition. The stress is equal to force divided by the area. The force in this case is 1 kilonewton. Thus force divided by the area is given as 2.5 megapascals. Similarly, the strain can now be found as stress divided by elastic modulus, which is equivalent to 0.371 strains. The displacement can now be evaluated as strain multiplied by original length, which is equivalent to 0.0142 mm.
Thank you, Dr. Nalami. You're now in a position where you're ready to use the ANSYS Preparatory Finite Element Simulation Suite at one of our workshops up and coming in the early part of March. In preparation for this particular workshop, we'd like you to do some calculations based on this steel specimen shown on this workshop preparation slide. Using appropriate diagrams, as in this lecture, we'd like you to detail the phases the specimen will go as it's pulled to destruction. And I went through a slide on that particular thing with Hooke, describing Hooke's law. I'd also like you to would also like you to evaluate the stress in each of the sections of the specimen, and we did that earlier in the lecture. Using the Young's modulus of 20,000 megapascals, once you've found the strains in B, we'd like you to find the values of the strains from the stresses. Finally, and you might have to do a little bit of thinking for this last bit, we'd like you to find the displacements, and the clue here is to find the displacement at this point, then the displacement at this point, and then you should be able to find the displacement at the final point. Keep an eye on our website, especially in the workshop area, and send your solutions to us on the email provided, and then at some point, once we've got up to our 20 students for our workshop, the solutions will appear on that particular website at a later date. So, just to tell you about the email is info@Murphy SEO Consultants, and we'd like you to respond to these questions: how to define a composite material, and how you think these workshops have got, these lectures and lessons have gone using the online part of. Also, we'd like you to try the quiz and obviously the workshop preparation with solutions to come at a later date. Just a note on the references, there is Kenneth Stroud and Dexter Booth's Foundation Mathematics, which for the first lesson. A lot of the second lesson was we used Bolton's book on engineering science, and if you have a look on there's obviously the classic text from Stroud and Dexter Booth called Engineering Mathematics. The first part of that is dedicated to foundation type lessons which you've been doing here, and because we've been talking about force, one should always include Isaac Newton's Principia Mathematica. It is written in Latin, but it's always worth a look, I think, as the classic text on the subject. Well, we'd like you all to. We hope you've enjoyed these series of lessons and lectures, and that you'll come to the workshop once you've done all the preparation for it. And we look forward to seeing you.